Hello friends, today I'll discuss about calculation of fault level at far end substation where local end substation fault level is known. So here the bus 1 is the local end substation and bus 2 is the far end or remote end substation. This two bus is connected via 132 kV double circuit line and with panther conductor. And local end, that is bus 1, fault level in terms of 3-phase fault current is 16 kiloampere or 3658 MVA. And in order to calculate the foreign substation fault level, we have assumed that base MVA as 100 MVA. So base impedance as 132 kV comes as kV square divided by MVA, that is 132 square divided by 100, which comes as 174.24 ohm. So the base current at 132 kV comes as C6, that is the base MVA divided by root 3 into base kV, that is 132, which comes as 0.4374 kiloampere. Now per unit current at 132 kV is given by C5, that is the C5 is 16 kiloampere divided by base current, that is 16 divided by 0.4374, which comes as 36.580. And source impedance is given by 1 divided by per unit current at 132 kV, which is given by 0.0273 per unit. And since it is a panther conductor, this circuit, so positive sequence impedance resistance for line, that is R1 is equal to 0.14 ohm per kilometer, and positive sequence reactance of line, that is X1 equal to 0.401 ohm per kilometer. It can be get from the conductor datasheet. So the total positive sequence impedance of the line, that is Z1L, is equal to root over of R1 square plus X1 square, that is 0.425 ohm per kilometer, and length of the transmission line is 100 kilometer. So total positive sequence impedance of the line in terms of per unit is equal to impedance of the line into line length and divided by that is the base impedance, that is 174.24, so which comes as 0.244 per unit. So number of circuit under parallel condition is 2 number, since it is a double circuit line, and total equivalent impedance of the transmission line, that is Z1 equivalent, is given by total positive sequence impedance of the line divided by number of circuit in parallel. So it comes as 0.244 divided by 2, which is equal to 0.122 per unit. So total impedance in terms of positive sequence is equal to Z1 source plus Z1 line equivalent, which is equal to 0.149, since it is a 0.122 plus 0.0273. So which comes as 1.149 per unit. So three-phase fault current at remote end bus, which comes as 1 divided by total positive sequence impedance, that is 1 divided by 0.149, which is equal to 6.702 per unit. So in terms of fault current in kiloampere, since the base current is 0.4374, so multiplying this, we will get the value of the fault current at remote end bus. It is 6.702 into 0.4374, which is equal to 2.931 kiloampere. Now the same configuration has been drawn in ETAP, that is in between bus 1 and bus 2 there exists one double circuit line, and bus 1 is the fault level is 16 kiloampere. So here it is considered as swing bus, and rating is 132 kV, and in terms of kiloampere, that is the three-phase fault current is 16 kiloampere, or in terms of MVA it is 3658 MVA, and bus 1 rating is 132 kV, and this two line has been connected via to the bus 2. So line 1 length is 100 kilometer and it is in service condition. And impedance of the line 1, that is the positive sequence impedance, is 0.14, and there is resistance, and X, that is the reactance, is 0.401 in terms of ohm per kilometer. Again, the line 2 length is 100 kilometer and the impedance is same, that is the resistance is 0.14 ohm and reactance is 0.401 ohm per kilometer. So we have considered that fault at bus 2. So we'll check what is the fault current at bus 2 for 3-phase fault at 132 kV bus 2. So the fault current comes as 2.9 kiloampere. It is supplied by the 132 kV bus 1 via this 2 line. So 1.5 kiloampere current will cater by line 1 and 1.5 kiloampere current will be catered by line 2. So under this condition, bus 1 voltage will drop to 108.404 kV. Now consider that one of the line is under shutdown condition, and under this condition what will be the fault current at bus 2. So in this condition we'll make it out of service. So we have make the line 2 out of service. So under this condition what is the fault current at bus 2? So let us check. So the bus 2 fault current comes as 1.6 kiloampere in terms of 3-phase current. Now we'll check whether this simulation is same with as per our Excel sheet. So since the line 2 is out of service, as it is under shutdown condition, we'll make number of circuit which is running under parallel condition as 1. So under these conditions, the 3-phase fault current at remote end bus comes as 1.613 kiloampere, or in terms of per unit it comes as 3.689 kiloampere per unit. So we can see that the calculation which we have done as per Excel sheet is at par with the ETAP simulation.